Hi, my name is Mike Vermeer. I'm Engineering Strategy Manager at Pandual Corporation. The journey of innovation rarely goes in a straight line. It is common for over a period of time for technology to advance in a linear way, but eventually disruption comes and completely changes the face of technology, changing use cases, changing how customers apply technology. And this is what we're facing a little bit in the area of Ethernet. And I wanted to share with you today some potential changes that require us to step back and take a look at what the overall potential is for Ethernet so that we can see some of the areas that maybe we haven't been looking at in the past, but that have an opportunity to even double the number of Ethernet connections in the market. So doing this really makes us take a step back and change our perspective. One thing that helped me take a different perspective on the opportunity of Ethernet is a video produced by Charles and Ray Eames by Charles and Ray Eames for IBM decades ago. But the neat thing about this video is it started with a picture of just a picnic site. And then as the video progressed, the viewing window expanded by a power of 10 every 2 seconds. And it was incredible to see the increased viewing area go from the city to the globe to the solar system and the galaxy and even beyond. This drew an analogy for me to the massive advances that Dr. Rick Pimpinella was just talking about with the evolution of Ethernet. These advances to twisted pair, high-frequency connectivity, as well as fiber optics, have completely changed our world and for the better, giving us massive capability for communications. But it makes you wonder, have we left anything behind? The interesting thing about that Powers of 10 video is that Powers of 10 go in the other direction as well. They go down into the negative and microscopic scale to the cellular structures and DNA and even down to the angstrom scale at the atomic level. And drawing the parallel, what we've seen is as we've been pursuing ever faster bandwidth, the application narrows to data center and central office applications. Meanwhile, there have been devices that have needed communications, but for which Ethernet was just overkill. It was more complex for both the physical layer as well as the chipset and the electronics required. So I want to talk about a little bit about those applications known as field bus. And before we get into the field bus serial communications themselves, the most basic type of communication can be considered to be a sensor, where a sensor will put either a voltage or a current signal on a wire, and based on the level of that voltage or current level, that will identify a certain maybe temperature or other physical parameter of the system. Now, customers wanted to have more data, more devices per wire, so they didn't have so many wires. And based on this, serial communications developed, and systems such as BACnet had developed for HVAC, heating, ventilation, and air conditioning systems. And this allowed variable air valves and controllers and sensors to all communicate together within a system so that a building could become a little more intelligent. Similarly, in process automation for chemical processing as well as wastewater processing, protocols such as Profibus developed to help communicate between pumps and drives and sensors and valves to help make the entire system operate, all the devices communicating together. And while we think these are past, really this is state-of-the-art technology that's still being used today. And what I want to highlight is some of the challenges faced by using these field bus systems in a world where the advancement of Ethernet means that every company wants to be able to create a unified architecture for all of their data. And some of the challenges includes the complexity of both installing and maintaining the field buses, the data silos that are inherently created, as well as the bandwidth limitations. By the very nature of field bus and the different field buses for each application, specialists are created, and customers need to hire these specialists to design their systems to make them work exactly the way they need to. When they're designed in this way, data silos are created so that all of the data for the heating, ventilation, air conditioning system, or the intelligent lighting system, or the process automation system, all of these systems have their data separately and manage their data separately. For a customer to want to take access control data and tie it into lighting data and tying it into the HVAC system, they actually need to add more gateways and hire new experts that can pull all that data together and help them build an even more intelligent system. There's a better way, and the better way is for all of these systems to communicate over Ethernet. And what has been developed now is a technology by the IEEE through their 802.3 subcommittee. They've developed single-pair Ethernet. So it's a new physical layer technology. The advantage of single-pair Ethernet is that the entire stack, except the physical layer, from the data link layer all the way through the application layer, remains. So that just as Ethernet operates over twisted pair cabling, four-pair cabling, as well as over fiber optics, now it can operate over a single twisted pair. And it delivers 10 megabit per second Ethernet and does so over a full kilometer. So that 10 megabit per second Ethernet is 50 to 100 times the bandwidth that is provided by traditional field bus, and even greater when considering the protocols that are closer to analog. So it gives you a massive bandwidth increase for these applications. In addition, you're familiar with Power over Ethernet, PoE, and single-pair Ethernet provides a corollary to that known as single-pair Power over Ethernet, or SPoE. And this provides over that same single wire not only the data over that distance, but providing power as well. So you don't need to bring auxiliary power to these systems. Single-pair Ethernet is a physical layer technology. And Panduit is one of the first companies in the industry to develop a physical layer solution for cable and connectivity for single-pair Ethernet. Our focus, as we've developed this, is on the customer. And so our offering includes IP20 connectivity, IP67 connectivity, and cable to help customers get a head start and future-proof their systems. Our IP20 connector is based on the standards IEC committee that develops low-voltage connectivity and is really built to be extremely robust. The most important part of this connector is it's designed to be extremely simple to deploy so that a customer can deploy it in the field with really his hands, maybe at most a pliers, but it can be deployed rapidly in the field, very few pieces, and can be just simply crimped onto the wire and used. It's a reliable and robust connector. For IP67 connectivity, our approach has been to follow the needs of our customers. And the concern that our customers have is to be able to transition from their field bus systems to an Ethernet system. And so we've worked with the industry to help validate that the traditional M8 style connector, which is a circular screw-on connector with the A code pin out, can be used for single-pair Ethernet. So this is how we intend to provide IP67 connectivity, and it's already been validated to some extent in process automation and is used for process automation. The cable is a very basic but highly validated cable. The cable for single-pair Ethernet that we've launched is 18 gauge so that it provides full kilometer reach, not only for the data but also for the power. That 18 gauge cable is also shielded, with both a foil and a braid screen so that we can protect from not only high frequency but also low frequency noise, giving it really good EMI resistance. And of course, the cable intermates with both Panduit's IP20 and IP67 connectivity. The most important part of the system is that it's backwards compatible so that customers don't have to completely rip out their field bus systems and replace with single pair Ethernet systems. The opportunity that they have is to actually think through, as they're deploying BACnet or Profibus or Foundation field bus systems, that they can think through what is their migration path. Typically, the evolution of the devices in the automation system change more rapidly than the infrastructure itself. So think through, as your customers deploy their devices, what are going to be the next generations of devices that are deployed in this system? And the opportunity that we have with single pair Ethernet is help them future-proof the infrastructure that they put in place so that when they put in place a Profibus system or a BACnet system or a KNX system, we can help them think through the infrastructure that will support not only that existing field bus, but also help them evolve to single pair Ethernet without having to rip out all of that cable and replace it with new cable, improving the ROI and helping customers get to a more intelligent system. So as you can see, the building blocks are in place for this future field bus and single pair Ethernet. And I look forward to working with you as we continue on this journey of innovation. Thanks for your attention.